Hi folks, so in this video what we're going to do is complete the Leave Cert 2024 Section A questions. So this was the Leave Cert Higher Level Section A 2024, and as always with the paper in the Section A you're going to be given 4 problems and you're going to have to complete 3 of them. Now in this video what I'm going to do is I'm going to complete A1 first, then down to A2, A3 and A4. So I'm just going to complete them in that order there. And whatever one that you maybe need yourself, you can obviously fast forward to that one, but I'm going to start with this one, go down to this one, up to the third and then to the fourth. That's the sequence I'm going to do them here. So I'm going to zoom in on this one here to start off with, and this one here was based around the topic of perspective. So no problem here, it tells us here the image below shows a lotto play stand, so we can see the little lotto play stand here. The drawing on the right shows the plan and partially completed perspective view of a similar stand. The picture plane passes through the corner A on the base of the stand. Okay, and we can see here corner A is actually going through it, the picture plane, which is identified with PP. That's our horizon line down here, which is giving us our vanishing points, and then we have our ground line down here. Okay, it tells us then part A, complete the perspective drawing of the stand. Okay, so essentially they've partially completed it. Everything has been set up where we have our spectator, we've got our picture plane, horizon line with our vanishing points and our ground line. So as you can see, they've kind of given us a partially completed look of the side of it here. So if I was just to, I suppose, highlight with my marker here, looking at it here, it looks like they've kind of given us that line. They've given us the vertical line going up here like this. They've given us this line here. And look, you can see it goes down, and they've given us the bit of the slope. So it goes down to here, and they've clearly given us the slope part there. Okay, that slanted edge. Now, what they haven't given us, okay, they've kind of given us actually the direction of this guy, which clearly lines up with that, but they haven't actually given us that bit there and then this little pointy out bit here. So that's what we have to figure out, and we kind of have to determine that in the plan. So if I was just to use a little bit of indexing here, okay, let's say I was to call that point A, we'll just leave it as A, call this B, I'd have point C up here, there's D, there would be a point E there, then I would have F in here, now it's hard to see, apologies, F, then I would have G out here, and H joins back down to A. So if I was to label that, look, A is there, B is at the back, so if I was just to label that, C is on top, so it would actually be C comma B, then I would have D in this position, there's D, then it goes down here, and in the same position as D as I look down on top of it would be E, so D comma E is in the same position there, and then it would slant out a little bit, so that means that's F, okay, and then it would go all the way out to G, and by the looks of it, I think that there is G, okay, and then G goes into H, and looking at it here, that's actually H there. So you can see here, C and B is in this position, I've got D and E here, I've got F here, H here and G. So a lot of this is actually testing your visualization skills. So we have to basically complete that. Now, in usual, any lines that are going in this direction will vanish over to VP1. Any lines that are going in this direction, in this case vertical, will vanish to VP2 because they're going parallel to the guys that give you the vanishing points. So what I'm going to do here is they've kind of given us this guy. So that line is going there. So that means that line there, that edge going from F to G, which is this line, F to G, that means from VP1, I'm actually going to vanish outwards from here. Okay, and the point I want to find, we already have F, you can see here, F, if it comes down, that's F. Now I need to find G. So how do I find G? It's the spectator's view of G. So from the spectator, go to G, but I have to extend it until it hits the picture plane. Now, slide and set squares here. I'm going to project it down perpendicular to the picture plane, where G goes up, bring it down, and there we go. I have now found G. Okay, now I need to find H, and the easiest way for me to find H is simply this. So what I'm going to do is the spectator's view of H, which is there. So from the spectator, you can see H there. Now all I'm going to do is bring H until it hits the picture plane. You don't have to draw it all the way in. I actually will maybe this time. And where it hits the picture plane, I'm going to bring it down once again. We'll find that guy. So where H hits the picture plane, in line with the spectator, drop it down. And you can see where it actually intersects that line there, that's where it's going to be. So now I'm going to connect that in, And there we go. I've got the side profile. Now, using my marker, I'm just going to heavy that in so it stands out a little bit clearer on the screen. Try not to let the ink bleed. There we go. So I've got the side profile. Now that I've got the side profile, I have to build the rest of it. Okay, apologies for that. Now what I'm going to do is I'm going to build off the rest of it. So all the other lines are going in this direction. The top surface, okay, the face, all that, they're going in this direction. So every one of these guys is actually just going to vanish to VP2. So once we got the side profile, we've kind of the hard bit done. This is going to come over, come over. That guy's already gone over there. Now I'm going to vanish over this guy. I'm going to vanish over the bottom edge. And then this guy's already vanished over. So you can see they've all vanished over as far as VP2. Now it's a case of simply finding those points of where they end. Now the top point here, which is in relation to D and E, that's where it ends up here. So how do I find that? What I'm going to do there is simply bring it to the spectator, stop it at the picture plane, drop it down. So where that hits the picture plane, you drop it down. That's going to give me that first edge. So that goes as far as there. Now it slants, so it's going to do the same thing. It's going to slant, and that's where it slants as far as this point here. So same rules. Spectator's view. You can see it's hitting the picture plane there. Once again, let's bring it down. And that's going to hit there, but what's important here is I have to connect that up, because that's the slanted surface. So that's connecting up to there. Now, how would I find where this ends? I could bring this guy down, really easy, but all I actually need to do is from VP1 I can vanish through this point to find where it ends there. Different ways you can go about it. So from VP1 I'm going to vanish through that. That's going to show me where that ends. Now the other point I want to find is the underneath surface here. I want to find that guy. So how do I find that guy? Well, I need to actually locate it up here. I'm just looking at it there, it's from height, so it's actually this guy, it's the hidden detail line here. Just making sure, yep, it's this one. From there to the spectator, you can see here, drop it down. It's actually hitting close enough to that G line, but I will project it regardless. So it's this guy here, the hidden detail line, brought down to here. And that's where it's hitting right there. And from there, I'm going to bring that across to here. And then just making sure, now it looks like that edge is finishing there, right here, but I'm going to check it just to be sure. See this little hidden detail? Because that's where the bottom edge will be. That point right there is the hidden detail in the plan view here. So what I'm going to do is I'm going to bring that, once again, down to the spectator. Going to zoom, check. And yeah, looks to me there like it is, and it actually is, so that's fine. Perfect. So I've got that proven. There we go. That's my object done. Simply a case, once again, I'm going to come along here now. I'm going to heavy it in. Just taking your time. Heavy in all the important lines. Trying to stop the ink bleeding there. Now obviously on the day of the exam you wouldn't use a marker like I'm using here, or a fine liner. You could, but I wouldn't encourage it. Okay, and there we go. That there is our platform, which is part A of the question done. Now what we're going to do is we're going to complete part B of the question. They'll always throw one of these little parts in, and it's just getting you to kind of think about how would you determine something. So it says here, part B, determine and indicate the overall height of the stand. So how can I actually work out what is the overall height of the stand? So basically what they're saying is, can I figure out what the height of the stand is, basically from this point B here up to C. So let's locate those. So B is on the ground, C is up here. Now, to be able to do that, what I need to do is technically take a height line, okay? Now, A, actually in this case, where A went through the picture plane, went through the object, which was at this point down here, I can use that as a height line because it's already here for me. because that there is actually technically point A, right there. Now, I want to use that to determine the height of the back edge there, because that is the overall height. And because I actually have B here and C, well, B is on the ground, therefore A is on the ground. So if I simply vanish C upwards like this and extend it on until it hits that height line, you can see here where I extended C out and it hits up here, and if I join that down to A, which it already is, that is my overall height. Determine and indicate the overall height of the stand. So my overall height of the stand is going from here down to here. Now, for the purpose of the video, I am just going to highlight that with a marker. Okay, highlight that with a marker. And what I would do probably on the day of the exam, could write in a little note, overall height of stand. Now, it says here determine and indicate, so I will actually measure it. And for me there, it's measuring at, I'm going to say 73. And there we go. That is the overall height. So by simply vanishing the back edge, which was the overall height, brought it forward until it hits the height line. That there is our first question done. Okay, so there guys is the first question based on the topic of perspective. We're going to go down here to the bottom one, and this is based around the area of the oblique plane. Okay, so it says here, question A2, the image below shows a ring display stand. Okay, so we can see the little ring here obviously sitting in the little display stand, and it tells us then the drawing on the right shows the plan and incomplete elevation of the display stand. The top surface of the stand is contained on the oblique plane VTH. So we have an oblique plane that is in here. We've got our traces, vertical trace, which is on the vertical plane, horizontal trace on the horizontal plane. And clearly we can see that the cut surface is the grey area here. And it is being cut by an oblique plane, and it's a truncated hexagonal base prism. It tells us here, part A, complete the elevation of the display stand, including all hidden detail. Now, essentially what we have here is, if I was once again to maybe label some points here, it's about finding, obviously I've got 6 points. Let's say I go with, this is A, B, C, D, E, and F. Well, we can clearly tell just on how I labelled it there, the 2 lowest points are A and B, the 2 tallest points are E and D, and the 2 in the middle are F and C. So, how would I locate those here? Now, what I'm going to do here is I'm going to locate all of them points here. Okay, so what we do here to locate points on the actual surface and elevation is simply this. I'm going to project parallel to the horizontal trace. So with the sliding set squares here, parallel to the horizontal trace, I'm going to go like that. Now it actually is at 60 degrees, so I don't actually need to do sliding set squares now that I'm realising it. I'm just going to check that to be certain. I'm assuming 60 degrees. Yeah, it actually is. So that's actually simply at 60 degrees, which actually makes my life a bit easier. Yep. My 60 degree set square, just zoom out there, you can see it, is set up perfectly on it. Okay, there we go. So if I project up parallel, I'm going to do the same with these 2 points. So parallel to HT in plan, and I'm going to do the same with these 2. Okay, so what I've done is parallel to the horizontal trace, because the principle we're using here is a series of horizontal cuts. Okay, so I'm going to go parallel to the horizontal trace. Then, where these 2 points here were projected parallel to the horizontal trace, I'm going to now go up to hit the vertical trace. Where it hits the vertical trace, I'm going to project across, because that line in elevation is my horizontal cut. That's what it looks like. Okay, a horizontal cut will appear parallel to the horizontal trace and plan, but it will be a horizontal line in elevation. And what I found here is my lowest 2 points. So in this case, it would be A and B. So I'm assuming then that maybe this one is A, this is B, and if I work my way around, I've obviously got C, D, E, and F. So there's my points. So, and you'll see here, just to prove it, B is directly below F. Likewise, C is directly below E. So there we go. Now what I want to do, let's find those points. So A is up here, B is there, so there's A, and I'm going to pop in B there. So there's the first 2 points. Now what I want to do next is I'm going to find C and F. Okay, so where C and F went up parallel to, they hit the XY line, parallel to the horizontal trace where it hits the XY line, projected up vertically to hit the vertical trace, projected horizontally across. Okay, now let's bring up C and F. So F has to come up higher. That's going to be F. And that's going to be C. So there's F. Put it on the outside. And there's C. Okay, there's my next 2 points. And now I want to find D and D. So I'll actually have to bring them up a little bit higher. D goes up. E goes up. And then we're projected up parallel to the horizontal trace, where it hits the XY line, projected up to hit the vertical trace, and where it hits the vertical trace, horizontally across, to locate our 2 points. So I've got E here and D here. So you can see the points. Excuse me. So you can see the points there that we have. We have now found the 6 points: A, B, C, D, E, and F. So I'm going to draw in the elevation. Nice question if you're familiar with the oblique plane. So A, B, and C, I can see all those edges. I can see the edge up as far as D. Okay, now I'm going to maybe in this line here. A to B will go in heavy. D to E goes in heavy. And then let's join in the back surfaces. Take my time here. There's that guy. C to D. F to E. A to F. And there we go. So there is the elevation done, but as always it says here include all hidden detail. So there'll be an edge here at the back for F that I can't see, and likewise with the edge for E. Okay, so there you go guys, that there is part A of the question done, using the principle of using horizontal cuts in an oblique plane. Now what we're going to do, it says here, is part B, determine and indicate the angle of inclination of the top surface of the display stand to the horizontal plane. Okay, that's a fancy way of saying the question is determine the inclination of the oblique plane. Okay, so it's how they're wording the question. Determine and indicate the angle of inclination. So what is the angle, okay, of inclination of the top surface, in this case the grey surface, that it makes with the ground? So what angle does that grey surface make with the ground? Imagine there that if that surface was to extend on and continued on down here, what angle would be inside there in relation to the ground? That's kind of what they're saying here. Okay, and that top surface, because it's the cut surface, it sits on the oblique plane. So as I said, it's a fancy way of saying determine the angle of inclination of the oblique plane in relation to the horizontal plane. So, a couple of ways we could do it. We could use the semicone method, but the method I like to use is one because it does help us. I'm just going to use the auxiliary method. So if I look along my horizontal trace and set up an auxiliary view, okay, and you can see they've clearly left us space here to do it that way. And the reason I'm not doing the semicone method is because my elevation and plan are already here, so it would get quite messy. So if I project up and look along the horizontal trace, which rests on the horizontal plane, I will see the trace as a point view. And because I only need 1 point on my vertical trace, I will then see the vertical trace as, the oblique plane, then the vertical trace, I'll see it as a line, but I'll see the oblique plane as an edge view, which gives me the angle of inclination. So, I'm going to, it doesn't really matter here, but I'm going to take this one, I'll take this little height here, I'm going to highlight that in yellow once again. That's going to be my little golden rule there. So I'm going to leave that there for a second. And now what I'm going to do is, my horizontal trace, we already know, is at 60 degrees. So I'm going to project out there, the HT, 60 degrees like that, just extend it. And then 60 plus 30 makes 90. So I'm going to set up my auxiliary view at 30 degrees like that. Really handy. I'm just going to go like this. Okay, and once again, that is my auxiliary view. It's orthographic projection here we're doing. That is my X1, Y1. And now, the height that I've taken here, okay, what I'm going to do is I'm going to project the point where it hits on the XY line, because that's actually where it's hitting. The vertical height is represented in the plan, that's actually hitting on the wall. I'm going to project that up. And what do I do then? I take the yellow height on my compass, So from the XY line, I project it from the plan, I take my height from the elevation. I'm going to take that height there, and I'm going to mark it, follow it up, and mark it out here. Now, right there, this right here is my horizontal trace. I'm going to write HT right there, but more importantly, I'm just going to write in a little note here. That is what's known as a point view of HT. It is a point view of my horizontal trace. Now, this is a point here that happens to be on my vertical trace. So because I'm seeing the horizontal trace as a line, as a point, apologies, I'm now then, once I join this up, that was a point on my vertical trace. So this is my vertical trace, VTH. And more importantly, what we've actually determined inside here is the angle of inclination of the cut surface. So, angle of inclination. Now it does say determine it again and indicate. So what should you do at this point when they do say that? You should always then measure it. So in this case we need our protractor. And what I usually do here then also, I'm just going to extend my line a bit further so I have a line to measure off. Use my pencil here. Okay. Position that point there. The zero is resting on the line. Quite happy with that. Now for me there, it's reading as 50. Pretty much reading 50 or 51 degrees. I'm going to take it that that's actually 50 degrees for me. Okay, so that's the number I'm going to write in there. Now I'd imagine on the day of the test, they would probably give you the little kind of range to get in. It's depending on your accuracy. These questions are quite small, but that's how we do it. That there, guys, is part B of the question done, based on the oblique plane. So I hope you found that one helpful. Now what we're going to do is we're going up to the question on the top right, which is based on the topic of skew lines. So I'm going to, once again, just move a couple of little things here. Apologies. So up here to the top right, just the visualizer here. There we go. Now, so this question here, it says here, A3, the image below shows two lightsabers. So you can see we've obviously got the red one and the blue one from Star Wars, from the Star Wars movie series. The lightsabers are represented by the two skew lines AB and CD on the right. So we've got AB in elevation, CD in elevation, and likewise in plan as well. It says here, part A, determine the projections of the shortest horizontal line between the skew lines. So this question can come up quite often, okay, and usually they'll either ask for what's known as the shortest horizontal distance or the shortest perpendicular distance. In this case, they've asked us for the shortest horizontal. So, skew lines question, what we need to do is we need to make a plane out of one of these lines, okay? Now, the method here is when you make the plane, what you're going to do is you're going to go parallel to one of the lines and you follow the same rule then down to the plan. So, I just have to look at it here and see which one is the most appropriate one. So if I went parallel here, I nearly go off the page, so it would. So I'm not going to use that. I think what I'm going to do here is A and C are at the same height. That would be kind of going way out there. So what I'm going to do here is I'm going to go parallel to the line AB. So if I go parallel to the line AB in elevation, generally it's done in the elevation, parallel to AB, like this, and I'm going to slide it across and I'm going to use point D as my point. So what I'm going to do is parallel to AB from D. Now, all I've done there is I've gone parallel to this line, like that, okay? And I use D as my reference point. Now from C we need to do a horizontal line across, and in this case it's actually handy for us because the line is actually already there. So I'm going to call that point P. Now, what I need to do is I need to find point P in the plan as well. And I'm going to follow the same principles that I just used there. So, I want to go parallel to AB from D. So in this case, same thing in plan. Parallel to AB in plan, same rules. Parallel to AB from D. So I do the exact same thing. Okay, so all I've done is gone parallel to AB from D. Now that I have P in elevation, what am I going to do? I'm going to project P down. And I've now found P in plan. Now where does P connect to? P also connects to C. So that's what I have to join back to C. And what we've done here is we have created a plane PDC. Okay, but more importantly, on that plane, I'm going to highlight it in a different colour now. I'm just going to use a yellow. Okay, because the line from P to C in elevation is a horizontal line, because it's horizontal in elevation, that means in the plan view, I'm going to actually see that line as what's known as a true length. Okay, that is a true length. So now, if we look along a true length, okay, that's on a surface, the line the line from P to C, yes, which is a true length, it's on the surface or the lamina PDC. If I look along a true length that's on a surface, I will then see that surface as an edge view. Okay, so what I'm going to do is I'm going to project out all my points along the true length, and I'm going to set up my auxiliary view perpendicular to that. So using the yellow line as my reference, I'm going to project out here. I'm going to project out all the guys at the same time. And we're going to project from the plan and take our heights from the elevation. Now, a bit of advice here on this question, you need a good sharp pencil. So there's all my lines being projected out. I'm going to rotate my set square to go perpendicular. And keep it quite close, just to save a bit of space. I should come out a little bit. No, because I'm only using those, so I'll actually have room, yeah. Okay. And that there is what's known as my x1, y1. Once again, that's my auxiliary view. Okay. Now that I've done that, I've projected from the plan, I take my heights from the elevation. Now what I usually would do here is I would line up A with A, just so I get the vertical height, C with C. Now that's so small I might have to not use my compass for that. D with D, just so I have the vertical height, and B with B. Okay, so there's all my vertical heights. Now I'm going to start with B, just because it's the tallest. So measuring from the XY line up to B, like that, and follow down to B here, and mark from the x1, y1 out. There's B. Now I'm going to take the height for D. Mark out to D there. Follow it out. Okay. Now this is quite small for me to be able to take with my compass, as you can see there. It's just a little bit challenging. So what I'm actually going to do here is I'll simply measure it. Now looking in there, to me there that's reading as 4 millimeters. Look from A down to the XY line, and it's the same distance for C. So from A, from the x1, y1, I'm going to mark 4 millimeters out, and the same with C. Okay, so I've done that. I want to put in my labels once again. So this now, when I label it, I'm going to call this D1 and B1. Then I've got A1 and C1. Okay, now what should happen here is that the two skew lines should appear parallel. So if I join A1 to B1, before I even draw it in, what I like to do is I like to check. So I'm doing a bit of sliding set squares here. Slide it along. Let's have a little check and let's see. Yeah, that's actually pretty good now. Quite happy with that. Okay, so there we have our two skew lines. Okay, so the first part of the question is done here, not this part A, but the general work that we have to do. Now this is where everything at this point would stay the same regardless of the skew lines question. Where it can change is what's said here. They've asked us for the shortest horizontal distance, or the shortest horizontal line. So what I need to do now is I need to set up a second auxiliary, and it's going to be projected perpendicular. Okay, I'm going to be setting up the second auxiliary, my x2, y2, and it's going to be perpendicular to my x1, y1. Okay, and I'm going to project in this direction, which is the space we have here. So starting off, what I'm going to do is, using my x1, y1, what I'm going to do is I'm going to rotate it, and I'm going to set up an x2, y2. That is my x2, y2, and all my points are going to project out perpendicular to that. So look, B will come out, D will come out, and A and C. Now they should be both in the same one. Yep. Okay, and just for labeling purposes, that's my x2, y2. Now where do I take my measurements from? The previous XY line back, which is the X1, Y1 back. So starting with A, X1, Y1 back, as far as A, I'm just going to adjust the lead there. There we go. And I'm going to mark out A from the X2, Y2. So that's my new A. Now I'm going to take the distance for B. X1, Y1 back to B. Doesn't really matter which one you do. There's B. I'm going to mark it out from the X2, Y2. I'm going to do D next. There's D. Follow it out here. And finally, C. Okay, out along the same line that A was projected. And there's C. Once again, a little bit of labelling. This point now becomes B2. Then I've got D2, C2, and A2. So let's join them all together. So A2 connects to B2. At this point you actually have a lot of the hard work done. Now what we have is a view where we've got the points, or sorry, the lines, they look like they're intersecting, they're not. In reality they're actually a bit of a distance apart. But at the point where they intersect in the view, that there is our SHD, our shortest horizontal distance. Now, we actually have to bring that and show it in all the views. The first auxiliary, it's already done here. First auxiliary, the second, the plan view, and then the elevation. And in the elevation, it should appear as a straight line. I say a straight line, sorry, a horizontal line. So, working backwards. Apologies, as usual, the lights go out in the room here, so I'm just going to get up and move there, guys. Apologies. Go. So, working back, I'm going to project back along my views now. So just using the lines that are already there. From the SHD, where the two of them intersect, project it back, but heavy it in. That is what my shortest horizontal distance looks like. So that's where it intersects with the line AB. This is where it seems to intersect with the line CD. Now I have to bring it back to the plan. I hope this works out. Looks to me it's about there. Now you can get discrepancies in lines, but so that's on the line AB. So I project it across. That's where it's hitting there. And this one looks like it's already done, to be honest. It's on the line CD, which is there. Now, essentially, what do I have to join? This is where it was on the line AB. Follow it back. That's that one. And this is where it was on the line CD. Now, this is where you can get discrepancies, so just be careful here. Put the line in. Now, that is the plan view. Now we have to bring it up to the elevation. And this is where, hopefully, it all works out. Now, what I'm going to do is here, it looks like I had it there, so I'm going to bring up this one first, the CD one. And you can see it's hitting up here. Now, usually what I would do here is I would actually draw a horizontal line across the hit AB and project it down. But I'm just going to check this first. I want to see, does it look like it's... Yeah, that looks to me like it's about right. So look, bring this up. And you can see it's hitting there. Now, where it hits AB here, it should go horizontally across. And there we go. So it should appear as a shortest horizontal line. And that's the question done. Okay, so that's part A of the question done. Quite hard for that to work out, but do your method and you should get most of the marks, even if the line doesn't appear fully horizontal. More than likely you're going to get the bunch of that, I suppose the most of the marks. Okay, you might be deducted one for accuracy or something, but part B then, it says here, determine and indicate the true length between the points A and C. Okay, so what they're asking you to do is determine and indicate the true length between the points A and C. So I actually had that in yellow earlier, so I'm just going to draw the whole line across. I'm going to go beyond B this time. So I'm just going to put this in yellow. A to C this time. Last time it was C to P. This time it's A to C. So that's the line in elevation. So let's join them in plan. So I'm going to join them in plan. Now that I've joined them in plan, it says here, determine and indicate the true length between the points A and C. Well, this is actually pretty simple. A and C is a horizontal line in elevation, therefore A to C in plan has to be a true length. So there's another true length, but it does tell me to indicate. So once again, that's my true length from A to C. I'm going to measure it. I'm reading that as 42 millimeters. So I'm going to write there, true length, I'll write it in 42 millimeters. Okay, or 42, whatever you want to call it. So that's part B of the question done. Tick. Happy with that. Now we're going to move on, okay, to the final question at the bottom of the page. So that's the third one there, is based on the topic of skew lines. Really popular question on the exams. Now, this last one down here is based around the area of solids in contact. So, it tells us here, the image below shows a sports cone and a football. The drawing on the right shows the elevation and incomplete plan of a similar sports cone, which we can see, we've got the cone in this, and there's the elevation and the plan is obviously incomplete. and football in contact with each other. Part A, complete the plan of the solids in contact. Okay, the elevation is already done for us, where we've obviously got the ball, which is represented by a sphere, and it's in contact with the sports cone, which is represented by a truncated cone, where the top of it clearly has been cut off. Now in the plan view, we've got the truncated cone, where we can see the top circle, the inner circle I suppose, and then the outer circle, okay, which is where it's resting on the ground. What we're clearly missing is the sphere. Now, how do I go about this? What I actually need to do first of all to get the sphere in its exact position is, I need to first of all find the position of the sphere when it's in contact on the outside, okay? What I mean by that is the outside of the cone. In this case, it's extreme generator. So, what we do know about the sphere is, the sphere's center height is exactly at this height, so it has to remain at that height, okay? Now the easiest way for me to do that is, if you bisect the angle that's created between the extreme generator of the cone and the XY line, anywhere along there you can draw a sphere, or a circle, that will be in contact with both the extreme generator and the XY line. So if I use that principle, so I'm going to put my compass here at the base of the cone, and I'm going to bisect the angle. And see how neat and tidy you have to be here. I'm going to bisect the angle between the extreme generator and the XY line. Now, I'm going to make this a little bit larger now. I'm just going to adjust it to keep it neat. Down to there. Keep the same size now on your compass. And up to there. Now, if I project that back, not project it, or join that back to the corner, I should say. Anywhere along that bisector, technically, I could draw a circle here, and it will touch both the XY line and the extreme generator of the cone. If I do one here, same principle, it will touch the XY line and here. But what I've actually found really that's important to me is the center point of this sphere, okay, when it's in contact with the extreme generator, which in plan is represented by this horizontal line going from the apex down to here, okay. That line there is this line in plan. So the extreme generator of the cone is this line in plan. So what I've found there is the center point when it's at the side. Now if you want, I could draw it in, so I could take the radius. Usually this is called using what's known as a ghost sphere. I'm just going to put it in ever so lightly, as best I can. Now you don't have to draw this, but just for demonstration purpose I am putting it in. You can see it there ever so light. You can see the outer edge of it. Now that I have it at the side, what I'm trying to do is I want to bring it down and then rotate it until it's in its correct position. So the ghost sphere, which I've after creating, I'm going to bring the center point of the ghost sphere down, okay, and locate it once again when it's at the side. So, as I said, it'll be the same radius. So look, remember that radius I had here? I could draw that ghost sphere in. I will put it in just for demonstration purposes, really lightly. That's the ghost sphere when it's at the side of the cone. However, that's not the actual position I want it to be in. Okay? The position I want it to be in is here. That's where the general center is, the actual center. So if I bring the actual center down, well, what happens? Think of it. the sphere is in contact with the cone, it will rotate around the cone using the center point of the cone as the rotational point. So from here, if I put my compass there at the center point of the cone, adjust it out to the center point of the ghost sphere, and rotate the sphere. Just like I've after, make sure that's accurate now. It's like I'm after rotating the sphere in this direction until it lands right here. Okay, and that is my actual center. But what we had to do is we had to determine it here. We couldn't just simply bring this out and then guess it. You had to find it by identifying the ghost sphere. So now I'm going to go back up. I'm going to take my radius from up here, and I can actually draw in now my cone using this center. So that's the one I'm going to heavy in a little bit more. And there we go. So there we have complete the plan of the solids in contact, and I can clearly see I'm after completing the plan of it. Now it does say complete the plan of solids in contact. Usually what you would do here is you would find what's known as the point of contact. They haven't actually asked us for it here. They've said complete the plan of the solids in contact. That's all they've asked us actually to do. Usually what you would do here though is you would identify where they touch. So I have to go back to my ghost sphere here, and if I use the center point, you go perpendicular to the extreme generator of the cone from the center point. So perpendicular to the extreme generator of the cone through the center. That will give me is what's known as the point of contact, but that's the point of contact on the extreme generator. I would then bring that down, and I would locate it on the ghost sphere in the plan. What do I do with that? Well, I would have to rotate it around, and the point of contact will always be where the two centers join. Center of the cone to the center of the sphere. But to locate it, now they haven't asked us for this, but I'm putting it in. I'm going to rotate that around. Like I rotated the center, the point of contact will also rotate. And there we go. That there is my point of contact, POC. Now I found the point of contact in plan. I also need to find an elevation, so that now needs to be brought up. And it will remain at the same height as the ghost sphere one. And then project it across. Right. And that then will be my point of contact in elevation. So that's part A done. They haven't asked us for the points of contact, not that I can tell anyway. So I don't think that would have been or marked down in the question if you didn't put it in. So it says here, part B, draw the plan and elevation of another sphere, which shall be in contact with the cone at point P, which we can locate and plan, and also rest on the horizontal plane. So this is kind of very similar to what I was just saying there, where we're going to use a ghost sphere and bring it around into position, but we don't know the height of it. Okay, the only thing we do know is the point of contact. So it's like I was saying about using this principle here. Okay, because the point of contact will join back to the center. Okay, so what we're going to do once again is we're going to bisect the angle. First of all, just going to start with that. Just going to bisect this angle here. The angle created between the extreme generator on the left and the XY line. I'm going to position this here and adjust my compass now, and I'm just going to enter the space. Okay, now that I've done that, what I'm going to do is I'm going to join this point here to the corner. That is my bisector of the extreme generator and the XY line. Anywhere along that bisector, I can describe a circle that will be in contact with both the extreme generator and the XY line. So if I did a vertical line here, it'll touch down here if I drew a circle, and it will also touch the extreme generator. So therefore, somewhere along there has to be a sphere that will touch the extreme generator. We know in the plan that extreme generator in elevation is this line in plan. Now it's in contact here, and we'll work around to that. What I want to do now is I want to actually find that point of contact up here in elevation. So easiest way to find that is if you see this point here, that's known as a generator line going from the apex down to the base. So if I find that point, I want to draw in that green generator. Now I found that point on the base, I'm going to connect it up to the apex. So that line that I've just drawn there is actually this green line. Now somewhere along that generator is point P. Now I can just simply bring up point P. So what I've found here now is point P, put it in orange, I found that in elevation. But what I want to do is I want to find point P when it's in contact on the extreme generator. Now there's two ways you could do this. The quick method is this. I could simply just go horizontally across like that, and that's the point of contact, like I said, when it's on the outside over here. Okay, it's represented by a horizontal line. In plan, that horizontal line is actually an arc. Just to show you, from P. So I could have rotated P. You can see where it hits the extreme generator. I could have brought that up. You can see it's hitting there. Now my axis is a tiny bit out, but you get the idea. Okay, so that point right there is where my sphere is meant to touch. So what did we do last time? We went perpendicular to the extreme generator through the center to locate our point of contact. We can do the same thing. We can go perpendicular through our extreme generator, but this time use the point of contact to locate the center. So that's the principle. So let's walk it around. I'm going to get my set squares. I'm going to set it up on the extreme generator. I'm going to go perpendicular to the extreme generator, but this time through the point of contact. And you can see it's cutting right there. That there is my center. Now once again, it's my center of the GO sphere. I'm not going to draw in the GO sphere this time. Okay? All I've done is I found the center of the GO sphere when it's at the side, like I had over here. So my center will be brought down and it'll be at the side. So, center of the GO sphere. I'm going to bring this guy down. And when it's the GO sphere, it's at the side. That is the center of the GO sphere plan. What do I have to do? The center point has to be in line with the point of contact. So I actually need to extend out this guy to find my new center. Okay, and I'm going to rotate, if I can find my compass, the center point around until it's in its correct position. And that's where it is. That is my real center. That is the real center. Now, how do I find the real center on elevation? I have to bring it up. I found the exact position and it will stay at the same height as the GO sphere. So that comes up and this guy goes across. And my radius then, to work it all out, found my actual center. There we go. My radius will be this. Put your compass there. I'm going to position my pencil down to the XY line. Don't worry that it's going to overlap. It is meant to overlap. Take our time. So there is the sphere. Now I'm going to put my compass here and draw it in plan. So that is my second sphere. Okay, now on the data test you probably have, you probably shouldn't do this on the data test, you'd have to use your compass properly, but that should be hidden detail as the sphere overlaps the edge of the cone. So there we have it, guys. The point of contact was already given to us because that's what we had to use for the question. Nice back on there, guys. So that there was the last question on that page, which was the solids in contact one. Okay, and there's the 4 questions fully complete from the 2024 exams. Now, more than likely, most students would have probably had to go with the perspective, definitely the Skew Lines, and then it would have maybe been a toss-up of these two. More than likely, majority of students would have gone for the Oblique Plane one. Not many students like this one, but nice question there on solids in contact. Okay, that's the questions done, guys. I hope you found that helpful. Okay.